data literacy out there of how we even talk and use data. There are extremers like to jump into R and programming and analysis and scientists, but most of us in L&D were not really data scientists or even analysts. So this is a light version of getting into data, but from the storytelling perspective. So why am I doing this presentation? Before we jumping into my story, I just wanted to see what your story is. And with that, I'm gonna move this thing out of the way. And if you have a cell phone or any other device or another tab, if you wanted to, if you jump into pauleve.com/Zsolt, and you should see this simple question of what's your data story. So where are you on the level of brand new to storytelling with data, all the way to you have extensive experience and you ended up accidentally on this call with the introductory part. So in theory, this should work on your phone, and we'll see if any answers are coming in. We'll
Good.
use this.
I dropped the link over, or the URL over in the chat, guys. You can copy and paste in your browser or use your phone.
Yeah, so either your phone or your browser, either way. We'll use this throughout the storytelling, because storytelling is not story talking, it's actually story sharing. So it should be at least on the level of conversational back and forth. So it seems like we have new and some using fundamentals and know about data. Nobody is up the top tier yet, which is good because you would be probably bored in this presentation. However, I'll tell you now that after the presentation, we'll put the deck and you can download it, because there's a lot more in this deck than for this hour. There's a whole section on just problem solving with data that you can use after as a step. So, all right, so it seems like we're a good space to start this and moving on to the presentation. So why am I here? I have two lives. One is the storytelling lives. I did write actually a screenplay that was a finalist in 2013. So I dabbled into the actual storytelling part for real. And the other side of me is this computer science programming that most people know, my work with JavaScript and everything else. So we're working with data and the creative part of storytelling at the same time for a while. And this is a passion that I think brings together two different mindsets, but when it's combined, it can be very powerful. So let's start with a quick story. This is actually a true story about my wife. When she was young in the early 80s, you see the mixtape type of era, if you remember that. She was really into science, and she begged her parents to buy this equipment that makes things bigger. So it's basically one is a binocular or anything that you use. In this case, they bought the best equipment they had on the market. And when this came to play with, there was a giant box, and it says something like that on the top. It says makes things bigger 100 times. I guess 100 times was back then in the 80s. So she started using it in the microscope, put everything under it, and watched it and work for a week. And then she put it away and never used it for like a week. And so her parents asking what happened. Did you didn't like it? You seemed like you were into that. And she said, yeah, it was perfect. I'm just saving it. And her parents are like, saving it for what? And then she goes, well, it says makes things bigger 100 times, and I already use it 50 times. And so I want to make sure that this 50 counts, so I'll save it for future work. So besides this, why I'm telling this funny story, one is that I think it's cute, but two is that it exactly represents what the problem is with our speaking data, the language, because this 100 is 100 for everyone. So the data there is the same. However, that we derive from the meaning of this is different. And obviously, she knows it now because she's a educational research scientist. But when you're young, you kind of misunderstand things. And it's not just age. It's just because our language generally are not focused on data. We're focused on a completely different meaning of those words. So for today, we're looking at quickly of why storytelling and why data together. what data is the best for stories. And we're going to go through a curious case of a correlation, the interactive part, and try to solve a problem. That problem solving with the middle, I'm not going to go through that today, but I'll leave you in the deck. There's a lot more details on how generally we follow those steps when you problem solve with data. And then we're going to look at some charts, visualization part, which is probably the most likely that you run into with data. So why storytelling and why data? Storytelling, as we know, is a very powerful emotional connection. Data is kind of the backbone. So you can combine these two together. And one, you can convince people based on facts, but you can also add the emotional part of it. We know that putting out numbers today, we've seen so many numbers on the screen, they don't mean anything anymore. You're not going to convince someone just by throwing more data at it. Yet telling one story with something that they connect to, and it's already a different way of looking at things. So the two together is a powerful combination. So I was wondering, in your organization today, in your role, what type of data you collect or use. That could be as simple as you looking at your learning and you have some scores and completion sort of thing, or anything else that today you're using in your organization, just to see what type of data is out there today in the world that we looking at in your organization. While you're typing, because this is a free form, it should be just a simple free text entry. I'll tell you that most organizations that I work with starts out with their SCORM. So you publish the e-learning in their LMS, and they want to know how many people completed it, where they, just like see course completions, how much time people spend on it, what is maybe the average score. And it really depends on what sector you're in. The private sector don't care about as much as the academia around the knowledge. They just want to make sure that things gets done. So we'll see, like, there's an academia person out here. There's a lot more going on in academia. In the private sector, it's usually about actually how much time they spend on training, because that's taking away people from actually being producing something. Test scores, yes, completion survey results, assessment questions, enrollments, completions. Yeah, so these are great. It looks like all of these elements, we have more test scores, interviews, completion, retention, engagement, trainings conducted, yeah, completely participated. Repeat learners, yep, a lot of organizations working on those nice decks of, how many hours people spend in training. Data for grants, so I see that academia is a different type of story here. Most of my experience is in the private sector, but data is data. So one thing that I noticed, there's a lot about numbers in your mentioning, and this is my experience as well, that when you think about data, people usually think about this, like a spreadsheet with tons of numbers, and then someone crunching those numbers and come up with some wise insights based on the numbers. But data is not just a spreadsheet of numbers. With storytelling, you think about data a very different perspective. It is the story, the hidden things behind those elements. And it's not just numbers, there's qualitative and quantitative data. So think that you see, you hear, you observe, there's all data. So one video interview is a great way to collect data. It's very different from spreadsheets and countable things, but it's still data. The other part of it is that to figure out for storytelling is not everything that you see is data that is important, and everything that you don't see shouldn't be discounted. So here's a simple example. This is from an artist who works with negative space. So negative space is basically things that you don't see, but it's there because as a contrast of what you do see. So if you have to describe this in some way, the easy part is the book and the characters, but then you get to this like strange midway think of, yeah, it's a book, but it's actually a forest. And that two together kind of makes you think about this whole story, about the meaning. Now, here's another one. Just by looking at this, the story that it tells is both the data that you see, the actions, and also the negative things. It's not there. So here's another one. This one tells you more and connects more about what the story is going to be and numbers with it than just explaining, let's say, the deforestation part of it. So it could be as simple as the things that we see is actually may not be what they are. So in this case, it's a simple graffiti, actually, a 3D spray that turn this like block of concrete into this art. Or here's another one with an alligator. So there is a lot that we can capture in the world to have a whole story, but you also need to think about kind of like a full story of what data is. This is more, I think, practical. New York Times is excellent graph that you can actually hover over every building in New York and see their time spent in the darkness, in shadows. So the data behind is a layer that can be telling an interesting story, but only focused on one thing. And this story is about how much time you spend in the dark. And then this one is more like a moving, simple GIF type of approach, showing the sea level rise. And again, the data, a visualization, and the story itself focused on one thing, and it's kind of tell you the story and at the same time see what's happening. So when we think about data, we're not just thinking about numbers, we think about the people and the actions and the context around it. In order to speak that language, Gartner puts it as one of the most important part for the next phase of our life, and was before the whole virus thing. Gartner claims that we do need to speak the basics of data in order to talk to those people who are immersed in data and smart with data. They might not both themselves know what to do with data and how to analyze. We need to come back as an L&D profession as the guiding questions and asking the right questions to make sure that the story that comes out is both valid based on data and also is compelling. So data literacy matters, great, but what is that for us? So for this webinar itself, very simple. You can define this as working with data, writing and analyzing, and just understanding data to be accomplish two things. One is not to be sold. So when you go to a foreign country and you learn a language, you don't want to be proficient on day one, but you don't want to be sold, and you don't want to be critically misunderstood. So these are the two things, very basic level, that we're going to go through today. So in your organization today, I wonder if you think about these words and expressions as data, information, knowledge, insight, where do you think you are? So how happy you are with the consistency of how your organization talking about these things. And that involves, you know, cross-functional teams, anybody in the organization. So we have some lightly green ones, most of them in the middle. And we have, I don't know, it's an orange one, almost angry. It seems like a lot of you are in the middle. So there is a way to improve talking and using these words and understanding the difference between them and have a common language inside the organization will be crucial, because otherwise you're asking for something and you get something else at the end. So let's talk about a little bit these four things: data, information, knowledge, and wisdom. What you see on the screen is 35. It's basically a raw observation. This is your data. 35 could be anything in the world. It's a number in the spreadsheet. Again, with the storytelling, we need to be aware that we're not just looking at numbers, throwing at machine learning algorithms to come up with another number, but these are actually observations some way controlled in a context with people. So 35 is the number, data. It could be anything in the world. When you put this number into context, in this case, speed limit, now it has a value for you because you know it's a traffic sign, and traffic signs controlling driving. Now you may not know exactly what to do with this sign if you never drove, or you have no idea how this works, but at least you know that this is a speed sign. Once you add the meaning to that, because you went through training and you learn how to drive, you know this is about a law, and this is the maximum speed limit driving in the area. So 35 is the maximum that you drive with. That's kind of like the meaning behind it. And then from this meaning, there's an insight that's coming. If you're driving with 10 miles per hour, you might just want to, raise your speed. And if you're driving at 50, you're way too fast, so you have to come down. So this is how kind of like building up data, information, knowledge, and wisdom in your head, all up to the action part. And this is what kind of was missing in the earlier story about the binocular, or the magnifier 100 times, is that the 100 was true. That was the data. Information around it was fine. However, the context and the insight were incorrect. So this can be incorrect. Just because you see the same thing, your end result and insight and the actions might not be true. So this little story is actually real. And I know the 3 looks a little funny, but what happened was actually they put a little Scotch tape on a real sign and to make it a little longer, and tested a Tesla self-driving car, and obviously the car recognized it as 85 and started speeding up to 85. Researchers had to smash on the brake. So this is why we humans are important in this process still, because it doesn't make sense. And all comes from our wisdom and general knowledge, not from the data itself. The data is data. Our conclusion should be different, and it was in that case. So let's see a case of this curious correlation. We need to solve a problem. Mixtape Corporation has 4 divisions: North, East, West, and South. They started out in the West, was smallest, and then they expanded overnight. They're selling mixtapes. However, the sales is down. And so last year they rolled out a sales training, new sales steps, and how to close and overcome objectives. It wasn't mandatory, so it was basically the manager who can decide who takes the training. That was a little back and forth between the sales VP. Sales VP wanted to lock this course down, so people have to listen to every audio on every screen and then move on. Apparently, the organization convinced them that it's not the best approach. People would be frustrated, so let's do a little test, and they can test out at least from part of it. So that's how the sales training was rolled out last year. Now, this year, after quarter 1, the results are in, and we were eager to see what and how went on with our sales VP. So when he comes in, this is the result that we'll see, which is not the most exciting and somewhat disappointing results. I'll let you read the problem here. So Mr. Rumor has a couple of things for us. He says the average performance trend seems like going down for those, gets worse, actually for those who actually took the training. And this is a disappointing correlation, obviously. It looks like our training actually caused worse performance. And probably the cause is because we convinced him not to lock down the course. So our job today is to dig deeper and find out what happened, and Mr. Rumor is right or wrong. So let's just start with the basic thing. They claim the average trend is going down. So this is something that you probably know what the average is. You get all the numbers and divide by the number of items. So in this case, it's 19 divided by 5, it's 3.8. This is how we calculate average. But it's good to know, back in the days of statistics from high school, that there are other averages in statistics like median and mode. Most of the time when we mean average, we actually mean mean. So if you talk to a data scientist or analyst and it's not clear what average, just tell them we want the mean. So the mean is 30.8. We know how they calculated it. The trend comes from this in sales. Now, what we need to know about generally about the mean is that it's a funny number because it might not even exist in the data set. 1 and 5 is the mean is 3, and there's no 1 and no, there's a 1 and 5 but no 3 in the data set. So when you think about the mean itself, sometimes it can be misleading. So maybe one bad apple in the sales training skewed our numbers. So we'll see if that's something that we can deal with. The other thing that they said is the trend. So the trend is relative. We know where they're going, so going down, but we don't know where they come from. Trend could be from 100% to 99, and that's negative. The actual performance is what actually captures the numbers, the KPIs before and after. So we need to know that too at some point. But we start with the trend, and the statement was that the trend is going down. So here's our sales metric. What they did, basically have a before and after test, and they averaged, in example, plus 9% is going up because before it was 75, and after that was 86%. And so they claim that this number, the before and after, is going downhill. They also say that people who did not take the training actually going up, and they're much better. So there is some kind of a correlation between these two. And that kind of brings up the question, what is a correlation? So when people say correlation, what they mean is that there is the relationship between two random variables, and it can be negative. So that might be that they're right. And what we would mean that there's this training and there's this performance trend, and over time they correlate. And unfortunately, this is not good news for us. So here's some potential correlations that you might see out in the world. Father's height and son height, taller fathers, taller sons, temperature and crimes. People come out, have fun, and commit more crimes. The learner score could be one of those correlations, or per capita cheese consumption and number of people died by becoming tangled in their bed sheets. So these are kind of potential correlations, which brings us to the big and most important point of whenever you see correlations, is that correlation is not causation. Just because two things look statistically correlated, and if they are, that doesn't mean that one caused the other. So this is the example of bedsheet tanglings and cheese consumed. They are correlated. They look very close as they're moving up. But that doesn't mean that just because people eat more cheese, for example, they gonna be more die on the bed sheets, unless you eat cheese, obviously, in your bed sheets. There are various reasons that why is it happening, and why correlation is not causation. Could be a lot of different ways. This one is a spurious correlation, where it's just coincidental, but it could be that something else causes it. That's kind of, you don't see a hidden thing in between them, that sort of thing. So we should be suspicious about every correlation we see. That's the starting point. So let's start crafting our story. We need to know what data we have, how it was collected, who collected it, and kind of when. And then we need to answer these questions. Is there a correlation between the average performance trends and whether salespeople took the training or not? And if there is, if you see this negative, was Mr. Rumor right? And if it's negative, is there a causation or just a coincidence? And then whether it's locking down the course was a mistake or not. So here's our data. This is what it looks like. We got actually two data sources to combine these things. One was the LMS, who took the training, when they took the training, that sort of thing. And the other one is coming from the sales training. So they define their own magic number for performance, and they measure them before and after and create the trend. So this is our spreadsheet thing. When we put this into Power BI, so Power BI, if you haven't used it, it's a free Microsoft tool that very easy to use to visualize things. Literally, you can import your spreadsheet from Excel. You see them on the right. Those are the variables, data, and then you can just plug in any of those visuals, and it creates you a demonstration of what it looks like in various ways. So it's an easy way to get into analytics or just visualization. We start playing with Power BI. So what it says for sales trend is that for those on the left, means -1 didn't take the training, is actually positive. It went up. And on the right, for those who did take the training, is way down -5.2. That looks like a strong correlation. That looks like something happened and our training is in trouble. So what do we do next? Do we just say, hey, there's a potential correlation? Yes, no, or we need more data to figure this out. What do we say to this sales trainer? Are they right or wrong? Or we need more data to dig into more details. Where do we go from here? Looks like we need to dig more. Nobody wanna gives up right now. All right, so far what happened is that it seems like this VP is right. So remember, it was trend. The trend is negative. What about the absolute value, the before and after actual performance? So on the left, you see the performance for those who did not take the training. And on the right, you see the performance of those who did take the training. And you see the darker blue is going down on the right and going up a little on the left. So based on this, we can say that, yeah, it's the same as the trend that we see. There is something fishy going on with those people who did the training. Does this thing tell us that our training caused people to be worse in their performance? Yes, no, or we need more data? Is this the point we stop? Still not? Still trying to get more? No, it doesn't say correlation, so we kind of split now. Good thinking. So while you're choosing this and thinking about this, artificially I put this giant red arrow on it to help you to actually see behind those graphs. Yes, we can see that the trend is going down, but we also see something very weird. If you compare the actual performance before even get to the training, the light blue, for those who did not take the training is like 80%. And those who did the training is like between 30 and 40%. Now that is something suspicious. So that's before they even sit down for the training. And what happens here is life. So when you think about how salespeople take training, is their managers tell them to do, because otherwise they're on the job selling. So what happened here is that managers apparently assigned this training to only those, or most of them, those who are already in trouble. Because if my guys are doing well, why would I take them over the phone and give them more training? So they assigned to those like, hey, can be worse, try this training. So what happened is actually a backwards causation based on interviews with managers, is that they actually caused, the low performance caused the training because that was the trigger for them to assign. So this is great news because it doesn't mean that our training caused the problem, and actually their problem caused our training. So question is, are we done here? Would it be the story to tell? Here's our chance to stop this webinar right here or move forward. So one option up there is you tell the story. Absolutely no, they were not right. The training did not cause worse performance, and that is our story. Second one goes a little further and saying performance was the outcome and performance was the actual trigger. So it kind of explains what happened. Then the next one is segmenting the data. And let's get deeper inside what did the training actually have just inside those who took the training. And then the last one is just running a machine learning algorithm just to see if there's anything come up. So I'm happy that you go with 3. 4 would be probably a option. The problem is that you just don't throw machine learning algorithms into data and see where you go without even knowing what's happening first. So segmentation is a good tool. We throw that into Power BI, and what we see is very interesting. These are the salespeople and their performance trend, and you see that there are 8 of them actually is from the early salespeople. The 8 of them who went up and the rest were down. So the down is because there's so many down negatives. That's what causing the average. But in this case, there is some hope. There is something going on because some people went up way up and others was all the way down. So that kind of the time when you get excited if you're a data analyst, because you're seeing a story, you see a puzzle, and you want to put this together. So you throw in a scatter. In the scatter plot, what we're trying to see if there is any correlation between the time spent in the training and the trend. So now you see that there is basically not really a correlation because the spots are all over. Some people spend like 5 minutes in it, others 1 and 14, but there's nothing to do correlating wise with the actual trend. But you see that 8 up there. So there is the hope. The question is, who are those 8 people and why are up there and why everybody's down here? It's not the time spent. It's something to do with other data points in the data set. So the next thing is segment. Let's say what else we segment by? We segment by regions. And segmenting by regions, you can see clearly that the West, the one who started, the smallest one, are way up and everybody's down. So there's something going on in the West. And those people are that you see on the dots are in the West. Okay, so that's great. We're onto something. We need to investigate what's happening in the West. So another data point that we have in the data set is whether the manager took the training or not. So we plot this out, and based on that, we can see that in the North division, which was one of the worst ones, most of the managers, a lot of managers took the training. And then in the West division are the fewest managers taking the training. So looking at this chart, what would your next step? So would you think that the more managers take the training, the worse the training impact is for some reason, or the more managers take the training, the better the impact is, or neither statement is correct based on this one graph? So would you go back and say, hey, North Division, it seems like people should not take the training if they're managers. Maybe they don't have time to coach, or I don't know. Sounds like we're all in agreement that this neither statement is correct. Oh, some people actually want that, want to claim that and stop here. So here's an example of a not really good graph for 2 reasons. One is North, East, South, and West are actual divisions. There is no continuous data on that scale. So basically they're distinct values. You cannot and should not do a line chart like that, because what it looks like to your eye is it's going downhill. It's almost like I can see over time it's going down some kind of a continuous value. Those should be just values by themselves, for one. And the other one is just by comparing the number of managers taking the training could lead you trouble, because there are a lot more managers in the North than in the West. Because remember, they were the smallest ones. So be careful with just looking at values as numbers versus percentage wise, because sometimes it leads you completely the opposite way. However, if you throw these managers into an overall graph, and on the left you see managers who did not take the training, and on the right, managers who did take the training, and their sales folks' performance, it clearly shows that those people who took the training as managers, their trend, their salespeople trend was way up and the others were down. So somehow there is something going on in the West Division when there are more trainers taking the training, and based on that, the value, the trend for their folks, the sales folks, are going up. Putting into one graph, this is kind of the winner story graph. Remember, this was the time spent in the training, but now we're a little introducing some colors. One thing that this says to Mr. Rumor is there's no correlation between the trend and time spent, obviously, because it could be from 5 to 14. However, if you color these dots based on whether the manager took the training or not, then it's clear that when the manager took the training, all these greens are above, so there's the positive ones, and everybody else is down. So our little story back that we would create and tell was that not only this training caused better performance, it caused it along, excuse me, along with the managers taking the training, which probably makes sense in real life, because if the manager takes the training, they have the ability to coach rather than saying, oh, do this, I have no idea what training you took. So taking it back to Mr. Rumor, this would be a good starting point of a conversation. And our suggestion would be maybe along the lines of, let's have the managers take the training first and then they decide, or have some kind of even a toolkit for managers of how to use the training, but those managers needs to be involved. And this is just a quick summary of what we went through the context, meaning, the finding, insights, and then actions go back to your stakeholders. So the fact that we can come back with an actionable insight, we can follow up on it, that's the most value that you can get out of data. This is the part that we're going to skip, but will be in the deck. And you can go through this. Basically, these are the steps we went through. And all of these are a lot more details of how in an organization you should go through data-driven problem solving and what happens when you jump in midway, which is what happened today, because the data was already collected and we jumped into the exploration and analyzation part. So we're going to run through this now. It's going to be in the deck. However, let's talk about the not to be sold part quickly. Edward Tufte is one of my favorite heroes out there in terms of data visualization. He has a nice saying about viewing research and novel things that you see that, oh, crazy, this is like game changer. He says that we should always approach novel research findings with an open mind, but never with an empty head. So this is going to be our motto, our mantra for the rest here when we look at charts, because every chart, behind every chart, there's an agenda. No matter who creates the chart, there's a story. You create the story itself, and you have a reason why you did that. Sometimes it is valid, sometimes it's unethical. So this is the checklist. We're going to go through the rest of the webinar here, looking at data visualizations. We need to look at the title. Is it a beef, normal title, or is it some sensational thing? The axis should be labeled. The scale would be indicated. And the pie chart, if you see a pie chart, they should come to 100%, because this is how our brain evaluates the pie chart. We talked about like continuous data and so on. And then, and then with every chart, you need to think about the agenda. If you create it, of what is your story, the one thing that you want to tell, and if not, or it was not you who created it, what was the agenda behind? So here's one thing, pie charts. You think about what's wrong with pie charts. Generally, it's easy. Don't ever use 3D pie charts to compare. This is the worst for a brain capacity and cognitive load perspective. One, the 3D shouldn't be used ever unless there is a third component, a third dimension that makes sense. This looks great, but if I ask you to compare the two sales quarters and which one, let's say, how did Brian perform, it would yet take you forever to figure out which one is bigger, which one is not, and what happened. And in fact, they're actually the same. We just actually turn it around a little bit. So pie charts, never use it for comparison, especially not in 3D. Best place to find, no matter where you're in the political spectrum, best place to find interesting chart is Fox News. So you can see in the presidential run, pie chart, again, kind of 3D. Numbers, you've had the numbers together, that's more than 100. Whenever you see that numbers don't end up, you should be absolutely suspicious about how it was created and what's the agenda behind it. Here's an actual example. This is a phishing problem. So not phishing as in lakes, but phishing as in cybersecurity. So in 2019, organizations sent out this phishing email internally and got the result. 2020, they sent the same email, got the result. And the comparison is what you see on the screen. So there are various problems with this. You should think about it. One, again, 3D, don't use 3D. Two, pie chart is the worst to compare two things. If you want to compare two things, there's a much better way to do that. And at the end of the presentation, I have a great resource to find what's the best slide or chart to do that. But there's a bigger problem here. One is that what is the story here? It's all like muddy up and you have to go back and forth between the numbers. If you're a cybersecurity expert and you want to hammer people into not opening the link, the worst thing they can do is opening up the link and then submit their credentials, because that is one person doing it in an organization could be devastating. So the biggest problem here is the 0.5 to 1.5 jump. So you can create a simple way of showing this and driving 1 point home is that the submitted, those people actually not just clicked on it, but typed their email address in and password and submitted or jumped from the last year's benchmark 3 times. If you look at this, you get the idea that there's something wrong and we need to act on it. Another Fox News thing. So I wonder if you can figure out what this thing is. I'll give you a couple of seconds. What's wrong with this? This is about Bush tax cuts back in the days. And when you look at this on TV, what it looks like is my tax gonna jump like crazy if they expire. The trick is very often used is that the Y X starts with 34. It does not start with 1 or 0. It starts with 34, which means it cuts off the bottom of this chart. And it has this very large scale. What happens if you put this same chart onto 0 to 40, then the difference would be insignificant. You can't really see the difference between the two. But this is the sensational way of seeing a huge jump in pie charts. Unemployment. This is another way of cheating. What it looks like story-wise is that the unemployment is going up and never came down. But if you actually look at the numbers, that 0.8.6 should be actually way lower than that yellow line. So the numbers are correct. It's just where they are on the scale, they're not. Funny. This is a new one that was just going on Twitter. In this case, the new cases per day for coronavirus. If you look at the Y again, the eyes following the lines, and your brain is literally thinking that those are those horizontal lines covering equal distances or depth or numbers or jumps. And if you look at the numbers, first is 30, then it's 30, then it's 10, then it's 30, then it's 30, then it's 30, 50, 10. They're all over the board. So this line does not look like what is for real. Again, there's an agenda behind these things when you see charts. And one more for Fox News, again, going up all the way. It sounds like, looks like there's a huge straight line here going up. And again, if you look at the chart with the Y, 94 million. It starts with 94, so you can see that moving up straight line in this figure. So how to use a chart depending on what your goal is. This is an excellent example of practical usable information that you can find out there. How we use this a little chart is start with the middle and you think about, okay, what would you like to show? Is it comparison? You compared something, two things. And then you go up and say, okay, that compared things over time as they change, or they fixed. And then you get to the chart. Well, best way to use the chart. If it's not comparison, let's say it's a relationship between two things, and you go to the left and you see the scatter chart that we used, for example, to show a relationship between time spent and trends. It can be also distribution over time that might change or not change, or a composition of pieces of of elements, and again, changing over time or not. So it's a great tool of just thinking about what you want to do, what your goal is, what is your story that you're telling, what is the one thing that you want to make sure that people get out of this, and then follow the chart through and use that. Again, you don't see many pie charts here. The only thing that may be down there is one simple share of a total of 100. The same site has also a presentation slide selector, so you can figure out what type of presentations build a slide for a presentation is the best. So this is a great tool. Again, it's going to be a deck and when you download everything here. And with all that, so where do you start if you're new to this and you want to make sure that there is some kind of progression going into data, working with data? So visualization part, or just working with spreadsheet. Excel is probably a good one to start with. There's our good free courses online to work with Excel. Pivot tables is like a #1 thing, the starting point that you start working with. And then that itself can get you closer to the type of data that you have in Excel and what information you can get out of those. Sometimes an organization use Excel for everything, and you have 15 different types of Excel sheets, and someone needs to combine those. And maybe they also have some online Salesforce that could be connected. This is where Microsoft Power BI comes in. So Microsoft Power BI has just the desktop version. It's free, or you can have the enterprise, more like pro version. But the good thing about that is, even if it's just you play for yourself, is that you can upload 3 different Excel sheets simply, and it does the rest. You can tell them how they're related, and then from there you can just build your visualization. And it's very intuitive to create those and figuring out what you see. To make it really useful and nice, like a dashboard, it takes some time, but it's a good way to throw in. And they also have good templates to starting with. If your organization is using Microsoft BI as an enterprise tool, then you can share these, and these can be dashboards, live dashboards that you update, let's say weekly or monthly. So we're working with clients when they wanted to see how we're doing learning-wise as a contract, different areas, and you can just create a dashboard. We refresh them weekly, and you can slice and dice the numbers in there. You don't have to send and spend time on Excel sheets every single week. Now, if you do want some advanced analysis and find causes and correlations and sort of thing, R and Python are the 2 starting languages here. They are very different in terms of languages, but either case, you get to the same library functionality. And R is open source. Probably you start with that and see what it does. There are either R or Python people there. So if they go to one bar, it's probably a fight after a while. So figure out which one works for you. Both of them work with Microsoft BI. So you can run an analysis in R or Python and then visualize it in Power BI. So in this case, for example, what we did manually, the segmentation part, the figuring out correlations, that sort of thing, in R would be 3 to 4 lines. It would be much easier to do once you know the basics. Tutorials, if you want to actually dive into solving problems, Kaggle.com is an interesting place because it not only has tutorials of R or Python and go through analysis, but it has data sets that you can play with. Even you can win money. So there's a lot of competitions going on out there. $10,000 if you build the best machine learning algorithm to win certain things. And then for data visualization, if you've never seen storytelling with data, that is a book that's absolutely recommended. Nancy Duarte, whatever Nancy Duarte does is great, but definitely one that goes through the explain data and inspire action through story. She breaks it down to slide by slide. I like that book. If you want into more around what you do to data, and it's a newer ways of approaching things. Storytelling with Data by Cole Knaflick. She's a great explainer with examples all over the book. And then Edward Tufte is more on the side of less practical, more like a beautiful data perspective of what you can do with data. What is the simplest way, the most elegant way, almost like the Apple of data to express something that you want. And then if you want actually a membership anywhere, this is the Society for Learning Analytics Research. It's a great place to connect with people who also do learning analytics and work with data. If you want to connect with me offline here, I have my Twitter handle. It's rabbitoreg. LinkedIn, there's only one, Zsolt Olah, kind of like the number one is actually give me the number one there. Blog, rabbitoreg.com. And I work for Kineo, so you can go to your Kineo site and see what we do as a learning consultant. And next time, if you want to see me speak, I usually go to conferences like 2-3 times, probably a year. This year is obviously an exception, but fingers crossed. Next time I'll be in Belgium doing storytelling with data somewhere in the fall, in October timeframe. Hopefully that will happen by then. So that was our session today about storytelling with data. I think two things that kind of you want to take away. One is data is always about people and actions and reality, and not just numbers that you collect. And two is that when you tell a story, pick the one thing, the most important part, the most important message, and frame it so the story and the data work together side by side. Creating too complex things won't make people happier or the explanation cleaner. And with that, that is my presentation, Alex.
Thank you. Thank you, Joel. Appreciate it. Thank you for that. Alex again here, guys. Awesome presentation. I think it was great. If you guys can unmute your mic and come up, let me know if you can or not. We got new security measures and so on. But this is the moment for you to ask questions. Any comments you'd like to add in the chat, use the chat as well. We got about 4 to 5 minutes that you guys can take advantage of that, okay? We got a thank you. That's fantastic from Janelle.
Thank you so much for attending. Obviously, you see that I'm holding back my passion, but I love working with data and the story at the same time. And remember that there's a lot more in the deck when you download about problem solving.
Elizabeth raised her hand. We got Elizabeth. Your mic is off. If it's on now, so you can speak.
Hey, it was really, really interesting. I'm still working, of course, but very interesting. Yeah, I was clapping because I couldn't figure out how to chat in the office. But yeah, no, it was really good. I don't have a question at the moment. Thank you.
All right, great. Thank you. Thank you for that. Yeah, I thought it was very interesting what you brought in, Zsolt. A lot of great tools, a lot of great references. The book was amazing. Any other comments, guys? Here we go. We got Russ Norton tells us, thank you. Love the points about data being skewed for bad agendas. Absolutely. That does happen. And aside from the books that he mentioned, one that I ran into the Leadership Masters I was doing back in the day, there was a 200% of Nothing, which is it's a great book. You should look up. It has a lot of anecdotes of how the propaganda and the data is given to you in different ways. But yeah, any other questions?
Yeah, there's another one, a classic of how to lie with statistics. That's an obvious one to look at. But just to back point to Ross's point, it's not just bad people creating data visuals that drive their agenda. It's every organization that you see when there's a presentation that is always in some way massaged to show you the best. So you always have to think about those elements. Look at the title, look at the scale, look at the numbers, and then if there's any issue, ask like, what happened to the quarter here?
Yeah, absolutely. So we got about 2 minutes left, guys. Any other questions? Go ahead and use the You can use the icons at the bottom of the chat. If you look at participants, there should be a little link icon. You can click on participants and see the panel. Here we go. I worked previously. We got Jenna Earls. I worked previously in dental research. We learned about how to interpret data, so much of what you said to what you said. So great, great resources and references. Thank you so much. So we got a lot of thank yous. Don't see any other questions popping in, Joel. I personally want to thank you for taking the time, especially in these times where, you know, a lot of people are getting busy in other areas and canceling and whatnot. So from the ATDCFL chapter and its members, I'd like to thank you so much. And this, guys, for any of you members that are watching and you're not, or if you're not here, we got a great attendance today. It was almost like 90% if we're going to do statistics. It was a mean of no, but
above the mean.
I really
Yeah.
want to thank everybody. Yeah, I put a link on the chat for you guys to give us your impression of this presentation as well. Give us your feedback, and also make sure that you let us know what is it that you would like to see coming in the future. We are going to work on giving you more online content as we go along, because obviously our face-to-face stuff is limited. So thank you everyone for showing up here, and thank you for being our members. Thank you, Joel. You guys have an awesome rest of the week.
Thank you so much for attending.
Bye.
See you. Have a good day.